Okay, let me 1 second, guys. Um, 1 second. Alright, so hi guys. I do want to apologize for the lack of uploads. I've just been so busy with because I'm dog sitting, so I thought I'd just do a really quick video right now while I still have time. Um, and actually look over um this function f of x. So now that we kind of see, what the difference quotient is, etc., what we're going to do is we're finally going to get into the actual definition of a limit. So the limit as x, I'm sorry, or not the definition of a limit, but the definition of a derivative. The limit as h approaches 0 of f of x plus h minus f of x all over h, right? And this is going to be considered f prime of x, where f is a derivative. So this is the idea of the definition of a derivative. And most of you, I'm sure, have learned this in Cal 1, or you're learning it right now in Cal 1. So yeah, so I kind of want to just go ahead and, show you guys how to do this. For this particular function, and the reason why I'm doing this one and as opposed to other ones like quadratics is because this one looks a little more tricky. So we want to find the derivative of this function, right? And like I said, find the derivative using definition. So the idea is, and we're going to treat this just like we did when we were doing um, difference quotient. So the first thing that I'm going to do is I'm going to try to find f of x plus h. So number one, find f of x plus h. And so this is the basic idea here. And so the way that this is going to work is I'm going to go ahead and do this. So basically, it's going to go like this. Hold on. I'm going to go like this. So I have f of x is equal to 1 over x. And I want to find f of x plus h, right? So again, I'm just going to distribute the the actual function here, or the actual term that we're not distribute. I'm gonna what is it called? Evaluate it. Excuse me. So I have f of x plus h, and I get 1 over x plus h, right? So this would be my f of x plus h here. So when I write it over here, I'm going to say that f prime of x is equal to the limit as h approaches 0 of f of x plus h. And like I said, this is f of x plus h. We just did that. So we're going to put, it's going to be of the quantity 1 over, let me actually do it this way, 1 over x plus h. And so that would be my f of x plus h there. And then minus f of x, so we're just going to do minus, and then our original function was 1 over x. So it's minus 1 over x, and then all over h, right? So now it's a matter of just cleaning this up and then finding the limit as h approaches 0. Obviously, we can't find the limit yet because we can't have a 0 in the denominator. So we have f prime of x, and it's going to be f prime of x is equal to the limit as h approaches 0, and it's going to be of the quantity 1 over, and the way that I'm going to do this is cross multiplication. So I'm going to say x, and then minus, and then it's going to be the quantity x plus h, so parentheses x plus h, all over, and then x plus h times x. So basically, I'm using this rule. If you guys just give me 1 second, hold on. So to kind of summarize what I did here, hold on. This is what I'm doing here, and I'm just kind of like I said, we're doing cross multiplication, multiplying this, and then putting it all over this, right? That's the idea here. So we have x minus the quantity x plus h all over x times x plus h. And then finally, what we do here, for this part at least, we distribute our negative, so then it'll be x minus h all over x times x plus h. And then this ends up being, so obviously these two cancel out. It's negative h over x times x plus h. And we're going to put that in for the top. So basically, this, like I said, it's exactly what I got over here. So we're going to just put, so like I said, if we look back here, we kind of simplified it over here, right? And the reason why I showed you guys this method is in case y'all didn't, I got the exact same thing here just by cross multiplying. But yeah, so we have negative h over x plus h times x. And notice that it's all over h, so we're going to do division by h. So here is going to be negative h over x times x plus h times 1 over h. And then finally, we're just going to take out that h value, and we end up getting negative 1 over x times x plus h. And now we have to find the limit as h approaches 0 of this stuff here. So when we plug it in by direct substitution, we end up getting negative 1 over the quantity x times x plus 0. And then if we do just a little bit of algebra here, we get negative 1 over x times x, which is equal to negative 1 over x squared. So we know that this is our derivative. So then, thus, f prime of x is equal to negative 1 over x squared. And that is how you find the derivative of this function using definition of a derivative. And so the idea is we have to understand this definition for calculus in order to, just because it comes back later, when you do Cal 2, Cal 3, it does come back. So we must understand how to do this very well. I will make another video over a different example on definition of derivatives, but for this video, I will stop right here. So with that being said, guys, thank you so much for watching, and also please like, comment, and or subscribe, and I will see you guys in the next video. Bye, guys.